Okay, hello class. Today we're going to be going over module 4.4. It's called perpendicular lines. And we're going to start with the perpendicular bisector theorem. So what the perpendicular bisector is, it's a bisector that cuts a segment in half, but it's also perpendicular to that line. So this is what it looks like. So here we have a line. So first of all, let's name it. So it's called line AB. What the perpendicular bisector does, it's just a segment that goes right through the middle of the line and it forms a 90-degree angle. So right at the intersection point, let's put another point. So really that's the perpendicular bisector there. So it's this segment right there. And right in the middle where they intersect, let's put another point there. So what the perpendicular bisector theorem says is that segment AC, which is all of this, so that's that segment AC right there, is congruent to segment CB. So those two sides are equal to each other, equal in measure. So let's go over an example of this. So you're applying the perpendicular bisector theorem. So it's saying, what is the length of CB if AC equals 10 feet? So we know AC is this segment right here, and it says it's 10 feet. Okay, so we know that AC and CB are congruent. So over here, we have over here, they're congruent. So if AC is 10 feet, that means that CB is also 10 feet. So that's what it means. It means that both segments on either side of the perpendicular bisector are congruent. Okay, so here's the next part. So this time they tell you that AB is 30 feet. And we're going to find the length of AC. So here AB is not just one half of the segment, it's actually the whole segment from A to B. So here they tell you that's 30 feet. So remember, 30 feet goes from there to there. So we know that's the whole segment. And since each part that the bisector splits is equal to each other, so we know that AC is congruent to CB, that means that each part will be half of 30. So you would say that half is 15 and the other half is 15. So here when they ask you what's the length of segment AC, because you only want one of the halves, you just say it's 15 feet. Okay, so on this next part, you need to recall the Pythagorean theorem. So just remember it's a squared plus b squared equals c squared. So we're going to be using this in the next part of our notes. So let's just go over a few examples of how to do this. So here we're going to solve for the value of c using the Pythagorean theorem. And you're given that a equals 3 and b equals 4. So starting off, again, remember that's the Pythagorean theorem, a squared plus b squared equals c squared. And you just replace the values that are given. So we have 3 squared plus 4 squared equals c squared. So then we have 9, which is 3 squared, 16, which is 4 squared, equals c squared. So 9 plus 16 gives us 25, equals c squared. And again, remember, to undo a square, we square root both sides. So square root of c. So just remember that the square root and a square, they can't eliminate each other. And then we have square root of 25, which is 5, or c equals 5. So that's answer there. Okay, let's go over another one. And this time they want you to solve for a using the Pythagorean theorem. And this time they give you that b equals 3 and c equals 7. So again, we start with a squared plus b squared equals c squared. And this time we have a squared plus 3 squared equals 7 squared. Or we have a squared plus 9 equals 49. So let's remember, the first thing you want to do is you want to subtract 9 from both sides. Then we just move the 9 over to isolate a squared. So we have a squared equals 40. And then we take to undo the square again, and we square root it. And now since we can't take the square root of 40, you do want to break it down into two multiples that multiply to give you 40, but we have a perfect square in one of them. So the two numbers you get here is 4 and then 10. Because 4 times 10 equals 40. But both of those numbers are still under a square root. So the only number we could take the square root of is 4, which gives the square root of 4 is 2. And the square root of 10, we can't do anything with that. So we get our answer as 2 square root of 10. Okay, so now go on to example 5 and work that on your own. Again, you could pause the video, and once you're done, continue on with the next part of the notes. Okay, so in this example 6, I want you to solve for the length of AD. And now, right now, AD is not drawn on your diagram here. Your line on your perpendicular bisector. So what AD is just the line that connects So what they give you is that they tell you that AC is 3. So A to C is 3. And they also say that segment DC is 2, which is right here. And the segment we're trying to look for, which is AD, is this segment right here. Okay. So again, this forms a right triangle, which you could use as the Pythagorean theorem to solve. So what we end up having here is you have 3 is our A value, 2 is our C value, and then not C value, sorry. Actually, it's our B value, and AD is our C value. So we have A, B, and C, and we could use the Pythagorean theorem. So what I said here was my A value is 3, or that side corresponds to AC. So that's why I put here AC squared. B is 2, or side CD. That's why I have CD squared. And my C side is AD. So that's why I wrote down AD squared. So now I'm just going to replace the values where they go. So AC is 3, CD is 2, and I don't know what my segment AD is yet. So I have that. So I have 3 squared plus 2 squared equals AD squared. And continuing on, I get 9 plus 4 equals AD squared. 9 plus 4 is 13. I have AD squared. So I square root both sides to get AD by itself. And again, square root and a square eliminate each other. And then the square root of 13, I cannot reduce it anymore. So I just end up saying AD equals square root of 13. Okay, let's go on to the next example. Example 7. Again, I want the system solve for the length of CD. And if I look at my diagram, CD is this segment right here. Okay, so let's see what information they give us. So it tells us that CB equals 5, which is the segment on the bottom. So CB equals 5 is right here. And also tell you that segment DB is 7. And again, it's not drawn on their paper yet, but let's connect that. So that means that this is segment DB right here. Let's put in the values where they go. So CB is 5, DB is 7, and again, we don't know what CD is yet. So let's remember that we could call this part A for our Pythagorean theorem. CD I mean is B. And then this segment here, the hypotenuse, is our 7. That's our C value. So we set up our Pythagorean theorem. We substitute in the values where they go. So we have 5 squared plus CD squared equals 7 squared. Or 25 plus CD squared equals 49. Again, we subtract 25 from both sides. Subtract 25 from 49. And what we end up getting here is we have CD squared equals 24. We take the square root of both sides. Again, remember the square root and the square eliminate each other. But 24, we could break this down into 4 times 6. And remember, both numbers still have the square root over them. And again, square root of 4 is 2. Square root of 6, we cannot do anything with it. So we're going to be getting CD is square root 2, square root of 6. So that is our answer for segment CD. Okay, so now try example 8. Actually, you don't have example 9, so just try example 8 on your own. And once you're done, let's continue on. So we're done with today's notes. You can get your stamp for today's work and start on your assignment.